Alright, we're going to look at solving basic log equations. So what I mean by basic log equations are things like this, where you really just kind of have to remember the definition of a log and how to translate an equation that's in log form into exponential form. So log base 3 of x equals 2, well, I have to solve for x, and whenever x is next to a log or inside the log, it's hard to solve it unless you can get it out of log form by using its exponential form. So if log base 3 of x is 2, that means that 3 to the 2 equals x, and now x is clearly 9. Okay, so there's a basic log equation. We teachers like to make problems seem more complicated than they are by doing things like this. Put an x plus 1 in there. The problem is not any harder, it just takes an extra step. Because if I want to write this in exponential form, I would write 4 to the 3 equals, and now I have to set equal to that whole thing, that whole x plus 1. So 4 to the 3 equals x plus 1. Now 4 to the 3 is 64 minus 1. Here we are. And sometimes we go the extra mile and we'll do things like throw in extra numbers to make the problem seem more complicated than it is. But again, all it really requires is one extra step. Now, the extra step in this case is that, in examples 1 and 2, I use the definition of log, right, to write it in exponential form, write the equation in exponential form. I can't do that yet because that 5 is a problem. I can only do it if I get this guy by itself. So to get it by itself, we simply subtract 5 from both sides first. And now I've got log base 2 of x minus 2 equal to negative 4. And now this problem is like 1 and 2. I want to write this in exponential form, remembering that 2 to the negative 4 is going to equal that whole inside x minus 2. Remembering what I know about law of exponents, 2 to the negative 4, well 2 to the 4 is 16, so 2 to the negative 4 is 1 over 2 to the 4, or 1 over 16. Again, if you're having issues with those law of exponents, those are handy to know, so maybe when you're doing Khan Academy practice, go to those. It probably won't take you too long, and you'll pick it up pretty quickly, just as a refresher there. And now add 2 to both sides. I get 2 and a 16th, right? 2 plus a 16th is 2 and a 16th. That's equal to x. Alright, and let's finish with the dreaded or the scary ln, which for some reason students think that's different than a log. It's not. It is a log. All ln is, the natural log, all it is log base e. Okay? But because e is such a special number that shows up in nature a lot, it's called the natural log. So why don't we call it NL instead of ln? Well, because I think the guy who formalized this idea was French, and they pronounce it like log naturel or something like that. Okay, but just remember, ln is just log with the base e. So if you want, just write in the little e there to remind yourself of that. And again, we can use the definition here to write this in log form. So now I have e to the 10 equals x squared. And I'm going to solve. Don't try to put e to the 10 in your calculator. We're not interested in the numerical value of that. We can leave it as it is for now. But to solve for x, since I have an x squared, I get a square root. And whenever you're solving an equation and you square root, you have to consider the positive and the negative value of that number. So plus or minus square root of e to the 10 is equal to x. Now technically we are done, but you can simplify e to the square root of e to the 10th a little bit, because e to the 10th, again, I can't emphasize enough, law properties of exponents are key, because e to the 10th is like e to the 5th times e to the 5th, or e to the 5th squared. And the square root of something squared is just that thing itself. right? The square root of 3 squared is 3. The square root of 9 squared is 9. So the square root of e to the 5th squared is e to the 5th. So perhaps a better way to represent the answer, or answers, would be like that. Plus or minus e to the 5th is x.